Right, so the two questions we're going to cover today are official GMAT questions. They're very tough. They deal with percent change. This is one, it's a problem-solving question. And then after that, we're going to do this data sufficiency question. Also very tough. But before we start with these actual GMAT questions, I want to deepen our understanding of percent change in general in the context of the GMAT. So we'll start with that, with just a kind of a basic understanding of like how we should think about percent change, and we'll work our way back to those official questions. So there's a very common job interview question that goes something like this. If your investment portfolio lost 20% last year, what percent must it gain this year to get back to its original starting point? You lost 20% last year. What percent gain will get you back to your original starting point? Very common job interview question. The common mistake that people make is they say, well, I lost 20, so that's minus 20. And what's the opposite of minus 20? Plus 20. And so they say, my answer is I would have to gain 20%. But that's not correct. And the reason it's not correct is because a percent change is not something additive. It's not something that you add and subtract. It's actually something multiplicative. I talk quite a lot about the difference between additive and multiplicative in the video I did for GMAT Club, which I'll link to in the description below and in the corner above me. We need to think about percent change as multiplying by something rather than as adding or subtracting something. So for example, if you're at the store and you're trying to figure out how much something will cost after tax, after the sales tax, and let's say that you live in a place with a 13% sales tax, when you pull out your calculator, there are two ways to do this, right? One way is to take the price, multiply it by 0.13, and then add it using the addition button to the original price. That's one way to do it. And when you do it that way, it kind of makes you think of it as something additive. The other way to do it is to take the original price and use the multiplication button, multiply by 1.13. When you do that, that kind of helps you think about percent change as something multiplicative. So obviously that's the way that I would recommend doing it going forward. Similarly, if you see a 20% discount, you could multiply the price by 0.2 and subtract that from the original, which I would not recommend. It's correct mathematically, but it makes you think of it as something additive. Instead, take the original price and multiply it by 0.8. So we're just multiplying and it's something multiplicative. Okay? So back to that job interview question. If the portfolio lost 20%, how should we think about that mathematically? What's the arithmetic that's happening there? Exactly, you're multiplying by 0.8. And what's the opposite of multiplying by 0.8? Dividing by 0.8. That's right. Now, is anyone here a fan of dividing by decimals? Is that something that we enjoy generally? No. So I think the better way to do these things is instead of thinking of it as multiplying by 0.8, think of it as multiplying by 4/5. And then instead of dividing by 0.8, you would be dividing by 4/5, which is the same as multiplying by 5/4. So the wrong way to do this question is to say, well, it's minus 20. The opposite of minus 20 is plus 20. Done. That's wrong. The right way to do it is to say, well, losing 20% means multiplying by 4/5. And the opposite of that is multiplying by 5/4. It's the reciprocal. If you're taking 20% off twice, it could be, oh, let's do the math, right? So when you have a 20% discount, you're multiplying by 0.8 or 4/5. And then when you do it again, you're multiplying again by 0.8 or 4/5. Now in this case, maybe I prefer the decimals because 0.8 times 0.8 is 0.64. So if you're multiplying by 0.64, what percent discount did you get?
36.
Precisely. So it sounded like you were getting 40% off, but really you only got 36% off.
Yeah, I think that's what that's how the retailers are like, oh yeah.
So that's what you were talking about, yeah.
Yeah, yeah.
Absolutely. So they'll definitely do that. They're not shy about it. Yeah. Good. Okay, I think this is all a good discussion. I think it's a deepening understanding of how percent change really works. And I want to show you, before we go to the original questions, I just want to show you a couple of ways in which the GMAT can get creative testing percent change. You know, the width of the rectangle is, excuse me, that's not the width, that's the length. The length is x, and the width is y. And then they'll say the length is increased by 30%. So imagine that, 30% increase for that length. And by the way, we probably shouldn't use a plus sign to represent a percent increase, because again, it makes us think of it as something additive, but it's actually something multiplicative. So I use the addition symbol there, but we probably shouldn't. And then they say the width is increased, let's say, by 50%. And the GMAT question would be, what happens to the area of the rectangle? Does it grow? Does it shrink? By what percent does it change? Right? And we know that the area of a rectangle is the product of the length and width. So it's going to be impacted by each of these percent changes. The 30% increase in the length will lead to a 30% increase in the area. And the 50% increase in the width will lead to a 50% increase in the area. So each of them is impacting the area separately. And what does that actually look like? We'd be multiplying by 1.3. So whatever the area was originally is going to be multiplied by 1.3 because the length got increased by 30%. And it's also going to be multiplied by 1.5 because the width was increased by 50%. So when you multiply those two together, I would think of that as 13 times 15. So 10 times 15 is 150, plus another 3 times 15 is 45. So 195, so 1.95. That's how I did that math. The area is getting multiplied by 1.95. That's the change factor. It's the factor by which the area has changed, which means that the area grew by 95%. So that would be the answer to that GMAT question. A couple of interesting insights that we can get here. One, the order doesn't matter. It doesn't matter if you increase the length first and then increase the width, or vice versa, because in the end of the day, we're just multiplying, and the order in multiplication doesn't matter. And this is something that they test a lot in the GMAT. The order doesn't matter. Going back to that job interview question, if we lost 20% last year, it would take an increase of 25% this year to get back to the original. But the opposite is also true. If we gained 25% last year, losing 20% this year would get us back to the original. The order of these things is irrelevant because you're just multiplying. And the order in multiplication doesn't matter. When a store asks you, imagine you're going to buy a car, right? And the car dealer says, would you like me to apply your 10% discount first and then charge you the sales tax? Or would you like me to figure out the sales tax first and then apply the 10% discount? The order doesn't matter. The order doesn't matter, and it does not depend on the sales tax. The sales tax could be whatever. And the discount could be whatever. As long as the discount is a percent and the sales tax is a percent, the order in which you apply those doesn't matter because you're just multiplying, and the order doesn't matter when you multiply. Now, if the discount is a dollar amount rather than a percent, well, that's a different story. right? If the dealer says, I'm going to give you $1,000 off of this car, would you like me to figure out the sales tax before I take off the $1,000 or after I take off the $1,000? What do y'all think would be a better option?
After you take off the $1,000, so the amount gets smaller, and then
Precisely.
only smaller.
Precisely. We'd be like, yes, please give me the $1,000 off first, then calculate the percent sales tax, because you'd be calculating it off of a smaller number. Exactly. So then the order matters. But if you're just dealing with a percent increase and percent decrease, the order doesn't matter. The one thing that we haven't yet discussed here is how do we convert from a percent change to a change factor and vice versa. Up until now, we just kind of assumed that it's obvious and everybody knows how to do it, but it gets a bit tricky when you have variables. So let's talk about that. We said that a 20% discount means multiplying by 0.8. Why? Why is that? What's the math happening in the background there? What's the math behind that? That's right. That's the correct way to do it. We'll take 100 as our starting point, and then we'll say, okay, 20% discount means we're losing 20 out of that 100. And then out of 100, that means 0.8. So when you think about, or 4/5, which we prefer, because fractions are better than decimals. So when you think about what we actually did here, we subtracted that percent discount from a starting point of 100, and then we divided out by that starting point. So if we were talking about an X% discount, we would have to do this. That's the factor by which the original is getting multiplied. So when you have some item that's discounted by X%, you would multiply that item by 100 minus X over 100. And if it was a Y% increase, let's say my investment portfolio increased by Y%, similarly, you'd add Y to that starting point of 100 and then divide out 100. That's the change factor. It's a factor by which the investment portfolio changed as a result of a Y% increase. So that's how we would translate from a percent change to a change factor. What about translating back from a change factor to a percent change? Remember that question with the area of a rectangle that we did? In that one, the question was wanted to know by what percent does the area of the rectangle change? And we ended up saying, since you're multiplying by 1.95, the area grew by 95%. So how did we come up with that percent change, the 95%? We took that 1.95, we took that change factor, we multiplied it by 100 to get 195, and then we subtracted out that 100. So it's kind of the reverse. It's the opposite of translating from percent change to change factor. You take the change factor, whatever it is, you multiply it by 100. So CF here is short for change factor. You multiply it by 100, and then you subtract out that 100 to get the percent change. If this ends up being something negative, that means you had a percent decrease. In our case, the change factor was 1.95 for the area of a rectangle, so multiply by 100 and subtract out the 100, and you get back to your percent change. So we're going to need these tools as we go back to those original questions. Those GMAT questions have variables for their percent changes, and that's kind of part of what makes them so hard. But if we know how to translate from a percent change to a change factor and vice versa, then we can use everything we just talked about with these change factors to solve those questions. And just to test that out with the multiplying by 5/4, that was going back to that job interview question, right? We said losing 20%, meaning we multiplied by 4/5. The opposite of that is multiplying by 5/4. So what is 5/4 as a percent change? You'd take 100 of those, 100 times 5/4, minus 100. So you reduce the 4 with 100, you get 25 times 5, so 125, and minus that 100, we get a 25% increase. So if your portfolio lost 20% last year, it needs to gain 25% this year to get back to its starting point. And again, I'll remind you, the order doesn't matter. If you gained 25% last year, losing 20% this year will also get you back to your starting point. So that was 2 minutes. Let's stop there. It's okay if you didn't manage to solve it. It is a very, very challenging question. But in terms of how to set this up, a k% increase means that we're going 100 plus k over 100. That's our change factor. This is what we talked about today. And an m% increase would be 100 plus m over 100. That's what we're multiplying by. So what are we looking at here? The first one is the price per share. Let's call that PPS. PPS is getting multiplied by that amount. And the earnings per share, let's call that EPS, is getting multiplied by this amount. And the question is interested in the ratio of PPS to EPS. In other words, if I put a fraction line there, that's the ratio that the question is interested in. So by what percent is that ratio changing? Well, I don't know by what percent it's changing, but I can tell you by what factor it's changing. It's getting multiplied by this change factor. It's getting multiplied by this change factor. This reminds me a lot of that rectangle question. The question with the rectangle wasn't asking about the length and it wasn't asking about the width. It was asking about the product of the length and width. And we said, well, the product of those will change by this change factor because of the length and by that change factor because of the width. This question is not asking about a product of two things. It's asking about a ratio of two things, but the concept is the same concept. The ratio of those things will change by this change factor here at the top because of the PPS and by this factor here at the bottom because of the EPS. So all we have left to do is to take that nasty looking fraction, that whole thing, and convert it into a percent change. How do we do that? We would multiply that thing by 100 and subtract 100. And that should give us the answer. Now, we shouldn't have to work so hard on the GMAT. I mean, taking this really nasty looking fraction and then simplifying it and then multiplying it by 100 and then subtracting 100, that's a lot of work. So I wonder if we look at the answer choices, is it possible that we can pick out the right one without actually doing any of the work? Think about what would happen as we simplify the fraction. Right? We take that fraction, we simplify it, meaning you'd multiply by the reciprocal of the denominator, and then multiply by 100 and then subtract 100. What wouldn't change as you do all of that? What would be, I wonder if any of you can figure that out. What could we say for sure about the correct answer? The denominator will end up being 100 plus m no matter what. And let me just take us one step into this to kind of help us see that. The first step we would do to simplify this is we would multiply by the reciprocal of the denominator, like that, right? And then let's not forget what we were going to do next is multiply by 100 and then subtract 100. That was the answer, right? That whole thing multiplied. So here's the multiplying by 100. That gets reduced. We end up with something that has a denominator of 100 plus m. And when we subtract 100 in the end, we'll have to do a common denominator. So we would rephrase that minus 100 as minus 100 over 100 plus m, just so that we would be able to solve the algebra. So in the end of the day, you're not going to get rid of that 100 plus m in the denominator. And do you think it's a coincidence that only one of the answer choices has that denominator? Or do you think they designed that on purpose to help us not have to work so hard? I agree, JD. It's the only answer choice that has that denominator for a reason. Right? They wanted to give an advantage to people who can kind of play the movie forward in their heads and think, well, this is what I would do next, this is what I would do after that, this is what I would do after that, and kind of see, well, after all those steps, I'm still going to have a denominator of 100 plus m, and then they can pick out the right answer without actually having to do any of the work. What do you think? Is it possible to solve this question in under 2 minutes? If you do that kind of thinking? But you really have to understand that a percent change can and should be thought of as a change factor and know how to translate from one to the other and vice versa. You really need to understand that. And then you also need that ability of thinking about the next couple of steps in your head without actually doing them and figuring out what that would look like. And then looking at the answer choices. The answer choices are there for a reason. I think a lot of people mistakenly ignore the answer choices and just try to do all of the math the way we did in middle school and high school. But we're supposed to use the answer choices to our advantage, so never forget that. So this would be an analogous question. Instead of a K percent increase, we have 70% increase. Instead of an M percent increase, we have a 20% increase, but otherwise this is the same question. Because the width is the ratio of area to length. So how would we solve it? We would say, here's the width. The width will change by a factor of, you'll have 100 plus 70 over 100 for the area, and 100 plus 20 over 100 for the length. So the width gets multiplied by this factor. And if you wanted it as a percent change, you'd multiply that whole thing by 100 and subtract 100. All right, so the width is the ratio of area to length. And in the original question, they were talking about the ratio of PPS to EPS. But it's the same thing mathematically. Yeah, the base values are irrelevant. That's really the beauty of change factors, is it helps you realize, wait, the starting points don't actually matter in and of themselves. We're just looking at the factors by which they changed. What they were to begin with is irrelevant. That's why the job interview question doesn't tell you what your portfolio was. How much was your portfolio worth in the beginning? How much is it worth in the end? How much is it worth in the middle? Nobody cares. Right? All you need for that job interview question is to know by what percent it decreased, and then you can infer by what percent it must increase to get back to its starting point. What was that starting point? How many dollars? Nobody cares. So what are the change factors here? We're going to have two of them, right? One for going from 97 to 98. What is it? Good. So that's a change factor for the first year. So the rent got multiplied by 100 plus x over 100 in the first year, and then it got multiplied by 100 minus y over 100 in the second year. And the question wants to know, was the rent after these two change factors were applied, was it greater than before they were applied? So you need to ask yourself, under what circumstances would multiplying by that make you bigger? In general, by what kind of change factor would you need to get multiplied by to grow? What would make you grow? A change factor that is what? I'm going to ask the question again. I'm going to ask it in a kind of creative way. I'm some number, not telling you what number, I'll just tell you that I'm some positive number. That's all you know about me. Okay, I'm a positive number. And I got multiplied by k. And as a result, I got bigger. What can you infer about the value of k? What must be true of k if I got bigger as a result of getting multiplied by it? So what would have to be true of this big expression that I have here in red in order for the answer to the question to be yes? If we want to say yes, the rent was greater in 99 than it was in 97, what would have to be true of this red expression? this expression represents the factor by which the rent has changed. So if the rent went up, that would imply that the factor was. So that's what this question is really asking. Is this expression greater than 1? Question mark. They're asking, is this change factor greater than 1? So in this case, I don't think we can completely avoid doing algebra. But the algebra isn't going to be super difficult. I think we should start by multiplying the whole inequality by 100 squared, and multiply by 100 twice because we've got 100 in each of those denominators. So what we'd be left with is 100 plus x times 100 minus y, right, is that greater than 100 squared? That's our rephrased question. And if we FOIL out the expression on the left, what do we get? We get 100 squared, which is going to, I'm about to cancel that out because I'll just subtract 100 squared from both sides. But we start with 100 squared. What do we get then? Plus 100x minus 100y minus xy. Is that greater than 100 squared? Yeah, it ends up being that statement 2 tells us exactly what we wanted to know, because once I subtract 100 squared from both sides, I'm left with 100 parentheses x minus y, right? Is that greater than, and I'm going to add xy to both sides, like that. And if you just divide both sides by 100, you get exactly what statement 2 is telling us. So statement 2 answers the question definitively, and statement 1 does not. Right? Knowing that x is greater than y does not answer our question. Yeah, so what you want to ask yourself is, does knowing that x is greater than y definitively tell me which of these sides is greater? Right? And what do we know if x is greater than y? We know that the right-hand side is positive. And the left-hand side must be positive because x is a percent that something grew and y is a percent that something shrunk. So they're definitely going to be positive. So, okay, so I know that both sides of this thing are positive, but which is bigger? No way for me to tell. So that's one way to convince yourself that statement 1 is not sufficient on its own. There's another way that I think is worth discussing, which is the following. If I know that something grew by x percent and then shrunk by y percent, and I know that x is greater than y, so it grew by a greater percent than it shrunk, is that enough for me to tell whether in the end of the day I'm bigger or smaller than my starting point? If you think back to the job interview question, what did we have there? We lost 20%, but in order to get back to our starting point, we had to gain 25%. That's always going to be true. The percent growth that you'll require in order to counteract a percent decrease is always going to be greater. Just as in the job interview question, 25 is greater than 20. So we lost 20%, but we needed 25% growth to get back to our starting point. So all statement 1 is telling us is that the percent growth was in fact greater than the percent decrease. Okay, but does that mean that we were able to more than compensate for the decrease? Or exactly compensate for the decrease? Or not quite compensate for the decrease? I don't know. I know that it would have to be greater in order to compensate for the decrease, but that's all we know, is that it was greater. I don't know if it was so much greater that I was able to more than compensate for the decrease, or just a little bit greater, not enough to compensate for the decrease, or maybe just the right amount greater, such that it exactly compensated for the decrease. I don't know which of those cases it is with statement 1, and that's a way to rule out sufficiency for statement one without using pen and paper. And just from that understanding from that job interview question, that you'd always need a greater percent increase than the percent decrease to get back to your starting point. Just from that understanding, you can think about statement one and realize this is not sufficient to answer the question because it would have to be greater, x would have to be greater than y to exactly compensate. And I don't know how much greater it is. So is it more than enough, less than enough, exactly enough? I don't know. And therefore, I can't answer the question with statement one on its own. Yeah, so that's a way to prove insufficiency, right? You can say, well, with statement one, it would be possible that x is 21 and y is 20. Or x could be 30 and y is 20. And we know from the job interview example that 25 and 20 is that break-even point. So 30 and 20 would give us one answer, and 21 and 20 would give us a different answer. And that would be a way to prove by testing cases that statement one is not sufficient on its own. That's right. So the GMAT will never ask explicitly for change factor because I invented the term change factor. It's an Avi term, right? And I invented it because it's so much easier to work with than percent change. So they'll never explicitly ask for change factor. However, they could ask for it implicitly. I'll give you an example. This is an actual GMAT question, right? They say an investment of D dollars, so they use a lowercase letter D dollars, produced with a simple annual interest rate, a constant simple annual interest rate, produced $600 of interest in 2 years. So this is the given information. And then they ask, in terms of D, right? In terms of D, what investment at the same constant simple annual interest rate would produce $2,400 in 3 years? This is a real GMAT question from the MBA.com practice test. You've seen that one, Padmanav?
Yeah.
So that's asking for a change factor, not explicitly. But when you look at the answer choices, you see all kinds of answers that have D in them, of course, multiplied by something. 2D, 3D, 10/3 D, 5/8 D, some factor multiplied by D. And the way to solve that is to say, look, on the one hand, we want quadruple the interest, right? We want $2,400 instead of $600, so that's quadruple the interest. And if you want quadruple the interest, you need quadruple the investment. So 4D. But we're not done yet. Remember, this is like this is part of the solution. We need 4D because we want quadruple the interest. Separately, instead of having only 2 years in which to accumulate the interest, we now have 3 years in which to accumulate the interest. So that's great. I actually don't need to invest as much as I thought I did because I have more time in which to accumulate this interest. Specifically, I have 3 halves as much time. Right? 3 years instead of 2 years. That's a change factor of 3 over 2, 3 halves. I have 3 halves as much time. Therefore, I will only need 2/3 as much investment. The reciprocal. So the answer is 2/3 of 4D, also known as 8/3 D. That's the correct answer there. So that's a change factor question, but they're not explicitly asking what's the change factor. They're just telling you there's D dollars invested. In terms of D, what will we need to invest for such and such? That's a change factor question. But almost always you'll see them as percent change questions. I think this example with the interest is a unique one. It's a unique example. So they can be asking for change factor, but that's pretty rare and it won't be explicit. And almost always it will be a percent change question. So change factor is more, it's not so much something that they ask for, it's more of just a tool that we use to solve percent change questions. That's how we should think about it. It's just when it's 2/3, 3 halves, it becomes a bit less intuitive, but you just want to practice that and start using that kind of language. I mean, when's the last time you said 3 halves? Is that a word that you say in everyday life? 3 halves or 5/3, or have you ever said I don't know. Today I drove at 8/5 the speed that I drove yesterday. When do you talk like that? Like, nobody talks like that. But think about it. If you're driving at 8/5 your speed from yesterday, then you'll get to your destination in 5/8 of the time. Because time it takes to get somewhere has a reciprocal relationship with how fast you're going. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.